Hello and welcome back to our series of tutorials on the Tanzu Application Platform GUI, our graphical user interface, and the foundation that it's built on, the Backstage open source project. We talked about the core functionality of Backstage and the core functionality of the Tanzu Application Platform GUI, or TAP GUI for short. Today I wanted to discuss in more detail how resource visibility is organized, how Kubernetes runtime resources are visualized in our Tanzu Application Platform GUI. And for that, I will need to start and draw our wonderful Tanzu logo paired with the Backstage logo, which I had some practice with, but still has a lot to be desired. So we'll start with drawing some illusionary boundaries around our Tanzu Application Platform GUI, TAP GUI. And once inside, once our user logged in, they need to select a specific component from the software catalog. So we'll go with the software catalog here, the software catalog plugin. We select a specific component, and maybe let's say component that is called My App. And from that component, we will be able to get to our specific plugin that gives us visibility into the Kubernetes resources called Runtime Resource Visibility plugin. Runtime Resource Visibility plugin. So that is the first element of our picture. The second one is describing and drawing some illusionary lines around the clusters that we want to inspect and see what runtime resources we can visualize here. So let's draw a TAP cluster here. That would also have some of its boundaries. And we'll also talk about some connection that permits the Runtime Resource Visibility plugin to fetch resources, fetch some resource visibility from here. Now, on that TAP cluster, we can have all types of different Kubernetes resources. But what we're specifically looking for is something that corresponds to the component that we're looking at. And I will denote some of these Kubernetes resources here. And the important part is that if we want our Runtime Resource Visibility plugin to visualize these resources, we need to make sure that the annotation that the resources are having is matching. So it can be any matching annotation that we want. For our best practices, we would recommend using a specific annotation that ends with part of equals the name of the component you're looking at. So in that case, it will be part of my app. And I will draw another imaginary boundary to get all the resources that have that same annotation here. So in the first access to the Runtime Resource Visibility, there is a kubectl request that will be sent by our Tanzu Application Platform GUI. And it will fetch all the resources with the matching annotations and will display it here for the user to see. The user will be able to answer the question, is my application up and running? Does it have any issues? Do I need to start troubleshooting it? All of these questions will be answered from that visualization. Now, I also need to mention that by design, by the design of this system, there will be some other Kubernetes resources that have different annotations or don't have any annotation whatsoever. I can refer to them as untagged, something they don't have the right tagging. So these resources won't be visible through this component, or if they don't have any matching component annotation on any component for that matter. That is part of the architecture that we're bringing here. Now, with that first run, I gave you the understanding of how Kubernetes resources are visualized, fetched, and visualized through our Tanzu Application Platform. Let me also talk about the different options that the operators can see, that the operators can employ to restrict some of the visibility of these resources. And for that, let me draw two different options where tab GUI visibility can be organized. I'll break it down into unrestricted and restricted, restricted and unrestricted. Now that, and I got two unrestricteds here, which I guess talks about my desire to unrestrict all the connections to resources to enable users to be more productive. Restricted. So the unrestricted mode talks about some service account that our tab GUI uses. Let me draw it here. So tab GUI is employing a certain service account that is the same for all of the users that would access it. And that service account has a very broad view rights on all the clusters that our tab GUI can connect to. So it will be used in our kubectl commands so that the tab cluster can fetch all the resources that are needed here. In the restricted mode, we are abandoning that service account. We're not using it anymore. We're not giving it to our tab GUI, but instead we're using all the users' permissions here. So if a certain user has the rights to view resources on that cluster, or has the right to view resources on a certain namespace or certain kind of resource, all of that will be taken into account, and that will shape the results that our Runtime Resource Visibility plugin right here would display. Let me complete that picture. So these are the two different modes of operation that would be chosen by the operator and would serve the needs of the organization that the Tanzu Application Platform is helping. That concludes our discussion of the Runtime Resource Visibility in the Tanzu Application Platform GUI. Today we showed to you how visibility is organized through certain components, and that the key to fetching those resources from different clusters is organized by matching labels, and that these labels just need to match, but as the best practice we recommend using the part of label. We also talked about the different modes of operation. With unrestricted mode, where tab GUI uses a specific service account that fetches all the resources it is allowed to view, to a more restricted mode where it takes users' permissions into account and fetches only the resources that these users have the right to see. That concludes our tutorial for today. Thank you so much for your attention, and we'll be happy to give you some more details on how our Tanzu application platform operates.